Hey guys, this is the second installment for your Unit 1 Geometric Transformations explanations. This section is the largest. It covers your questions 2, 5, 8, 9, 11, 13 through 18, so hang in there. It is going to be the longest video. Triangle A prime, B prime, C prime is the image of triangle ABC. Write the rule for the transformation. So I'm transforming from triangle 1 to triangle 2. On the test, I think I made the primes more readable. So I just want to pick a point and I want to see how it transforms or translates to get to the other point. 1, 2, 3, 4, 5, and down 2. So right 5, right 5, down 2. So that's going to look like x plus 5 and y minus 2, which will be option A. Right, in this case, right movement is always addition, left is always subtraction. Write a function rule using function notation. Right 3, down 4. So x, and I'm going to add 3, and then down y minus 4. So our answer choice is going to be option C. These so far, just knowing your rules and knowing that right is addition, down is subtraction, left is subtraction, up is addition. This one I just need to find my lines of reflection. So I can go through and look at each one. That one. That one. This one approximately. So this is x equals 1. This is y equals -1. X equals -1 and y equals +1. The question wanted us to find the line x equals 1, which is option A. How is the shape moving? That's really what this question is about. I want to pick a point, so I'm going to pick E, which is at -3, 4. That is my x and my y. And then I want to look at the prime point, the image point of that, which is at -4, -3. And these are also now my new x and my new y. How are those two changing? So if I look at this, my x came to the back. That's a weird parentheses. My x came to the back and didn't change at all. My y came to the front and changed signs. So the opposite of y comma x. Option D. So these, pick a point and see how it changes. Okay, so my first transformation, the first thing that happens is the right 3 and 2 units down. So x plus 3, y minus 2. That's just a rule. That is happening first, so I'm going to put it in parentheses. Then what comes next is a scale factor of 2, and 2 gets multiplied to both the x position and the y position. So now you could distribute it out if you were looking just to find, like, if I take an original point and try to change it all at once, you could do it that way. But in this case, we just need to keep it the way it is because option B is our choice there. So the movement left and the movement down comes first, and then your scale factor multiplies both of those. This question is talking about rigid motion, and I want to know, first of all, I think a lot of you forgot what rigid motion was. Rigid motion is just where I take something and I can slide it around my graph, I can spin it around, I can flip it over with the reflections. The only thing I cannot do that does not preserve rigid motion, does not keep the same size and shape, is the dilations. The dilations, making it bigger or smaller, changes the size of the shape, and that does not keep it the same size, so it does not preserve rigid motion. But in this case, I can look at it and say, oh, what this is happening here is a reflection and probably a translation. So it got reflected and then moved over some. So we decided that yes, it preserves rigid motion because it was only a reflection and a translation. Now we need to decide what the rule is going to be, and how I'm going to do that is look specifically at the reflection. So the reflection is going to be not necessarily over the y-axis, but a line, a vertical line somewhere in here, which is going to make it look like a reflection over the y-axis. So in that case, the rule for that is the x value is the one that changes, not the y. So if I look at my answer choices, I have x being the -1 or y being the -1. And since we decided the reflection over the y-axis makes the x change its value, your answer choice for this one is going to be answer choice A because of that negative. You could then go through and shift it right 2 and up 3. The up 3 is probably the easiest piece to see, but just knowing the reflection piece is the most important here. Identify the transformation of the figure below. Okay, so let's just look at this in a big picture kind of way. Translation. Did it stay in the same position but just slide left, right, up, down? Definitely not, because I've got V, and then I've got V prime over here, and the whole thing is just kind of shifted over, so it's not a translation. A reflection about the origin, it is not in the same position, is not a mirror image. Dilation, did it get bigger or smaller? Nope, same thing. Process of elimination is a rotation. You could, in this case, pick a point and see how it changes. W, which is at 1, 2, 1, and W prime, which is at -1, 2, and then say, how did those change? Well, the rule in this case would be the opposite of the Y, and then X stayed the same but moved to the back. That's how it moved, and that is a rotation rule for 90 counterclockwise. Which sequence of transformations occurred transform the triangle ABC? So this one, this original one here, and then here. So how am I going to go from 1 to 2? 1 to 2 is definitely a reflection. So I'm not translating and I'm not rotating. It is a reflection. Now we have to decide, is it over the X or over the Y? Over the Y would make it come over here. This one is literally over the X. And then our translation's 5 units left. You can pick a point and go, okay, how is this one changing? 1, 2, 3, 4, 5 in the left direction. So I'm reflecting over the X and then I'm translating 5 units left. Answer choice D. Given triangle ABC with points ABC, perform a dilation using the rule 3x, 3y and determine the scale factor. Okay, so scale factor, it tells you in the transformation. I'm going to take 3 and multiply by both. So my scale factor is 3. Now I need to actually perform that scale factor, multiplying the x and the y by 3. So -2, -4. And I'm going to do 3 times x and 3 times y. So a prime. 3 times -2 is a -6. And 3 times -4 is a -12. -6, -12. All you do is multiply through. Consider the parallelogram with coordinates A, B, C, and D. Find the coordinate of the point D after the following transformations have taken place. So let's walk through each one of these. A reflection over the x-axis. That means the y is changing, so x -y. Actually, I'm going to write it down here. X -y. Dilation of a scale factor of 3. Well, we just talked about that one. And the last one, right 6 and down 4. So I'm going to take point D through each one of those transformations. So D was at 10, -2. And I'm going to take each point and change it. So the first time it's going to become 10 and the opposite of y, which is positive. Then I'm going to take that and put it into the next one. And both x and y get multiplied by 3. So 30 and 6. Then I'm going to take that and plug it into the next one. 30 plus 6 gives me 36. And 6 take away 4 is 2. So that is how I end up with 36 and 2. So just write your rules for each one. Take it piece by piece. Plug it in one at a time and see what your end result is. All right, if you notice this right here on the graph, it looks kind of weird because there's random letters, but what this means is it is your released test item. So this is a Math 2 released test item. So you could see something definitely like this on your NCFE. Triangle EGF will be rotated 90 degrees counterclockwise around the origin. So I'm going to take a regular point, XY, and I'm going to transform that into rotated 90 counterclockwise, negative Y, comma X. That is my rule for a 90 counterclockwise. Okay, this is my new X and my new Y. Then I'm going to take it and reflect it across the Y axis. So when I do that, reflection over Y. Reflection over Y means the X is what changes. But remember, my X is now this negative Y. So the opposite of whatever was in the X spot is now a positive Y. And then the X stays the same. Because only for reflection of Y does the X position change signs. So now I have YX. And the question is now saying, how can I map this image that is at these kind of coordinates in relation to the original? How can I flip it back so that it is back in the XY position with those coordinates? So this is just being familiar with your rules and understanding really again what the question is saying as well. So if I look at my answer choices, rotations are just going to change signs and flip them back around again, and I don't want to do that. Reflection along the line y equals negative x changes the signs again, but along the line y equals x, it's going to take whatever was in the y position and the x position and flip them back. That is the rule. So what that's going to do is, remember in this case, it's not, I know they look the same, but it's saying whatever was in the Y position comes first and whatever was in the X position comes second. So these would flip back because this is your new X and your new Y. So it's reflecting along the line Y equals X. Okay, thanks for hanging in. If you have any questions about these, please do not hesitate to ask. We would love to help you better understand to get you better prepared so that you know your content. If you have any questions, let us know.